today course content is from your model 2, and we will cover the inter-process communication in today's class. So these are the course outline of today's class. First we will do brief introduction to the inter-process communication. Next is independent versus cooperating process. Next we will do shared memory and their advantages and disadvantages. Message passing model, advantages and disadvantages. Then we will cover the system call, different types of system calls, and there are some popular Windows Unix system calls are there that we will discuss. So these are the learning objective and the learning outcomes of our course. So after learning this course, a student can be able to analyze kernel and user mode in an operating system, evaluate and report appropriate design choices when solving real-world problems. So what is inter-process communication? So inter-process communication is the mechanism provided by the operating system that allows processes to communicate with each other. That means, assume there are two processes just in the diagram. In the process 1 and the process 2, assume that process 1 wants to interact with the process 2. So what will happen? So there must be one function call from, or there should be some interaction point from the process 1 by which process 1 will communicate with the process 2, or there will be some relationship between the, or some dependency between the process 1 and the process 2. So just go to the next point. This communication could involve a process letting another process to know that some event has occurred, or the transferring of data from one process to another. So in the below diagram, just see that there are some relationship or dependency, or there are some transmission of data will be occurred between process 1 and the process 2. So this kind of interaction is called inter-process communication. Now, there are two types of process. So one type of process is called the independent process, another type of process is called the cooperative process. So independent processes are, that means by name you can understand, they are not dependent to each other. That means process 1 and process 2 cannot be dependent to each other. So processes that executing concurrently in the operating system may be either independent processes or cooperative processes. If a process cannot affect or be affected by the other processes executing in the system, then the process is said to be independent. So any process that does not share any data with any other process is independent. That means process 1 and process 2, there will be no sharing of data or sharing of information. Then this kind of processes is called independent process. So a process is said to be cooperative process if it can affect or be affected by other processes executing in the system. So it is clear that any process which share its data with other processes is a cooperative process. That means whenever there are some dependency or sharing of information or sharing of memory location will be occurred, then process 1 and process 2 will be dependent process, or you can say it is a cooperative process. So when this inter-process communication occurred, so there are four situations where inter-process communication can occur. The first one is the information sharing, the second one is the computation speed up, the third one is the modularity, and the fourth one is the convenience. So what do you mean by information sharing? Since a number of users may be interested in the same piece of information, for example a shared file, you must provide a situation for allowing concurrent access to this information. So that means assume there is a file or memory location in your computer, which portion is in a sharing mode, or at the same time more than one process can access the file and retrieve the information from the file. So this kind of situation can also occur in case of inter-process communication. Next one is another reason is the computation speed up. Computation speed up means by parallel we are executing more than one process to increase the speed up of our execution of a particular algorithm or a task. So now see the what is we are giving in our presentation. If you want a particular work to run first, you must break it into subtasks where each of them will get executed in parallel with other tasks. Note that such a speedup can be attained only when the computer has compound or various processing elements like CPUs or I/O channels. The next one is the modularity. Modularity means we are dividing a big task or big work in a small piece of modules, and each modules are working or executing independent manner. So you may want to build a system in modular way by dividing the system function into split processor or threads. That means just I'm giving one real life example. Just like in our university or colleges, there are many working modular there. Some people are working in the admission module, some people are working as a faculty or teachers, some people are working in the lab portion, some people are working in the library, some people are working in the canteen, some people are working in the hostel or any other administrative task. Okay, so that means we are dividing a huge system into a small piece of modules, and these modules are may or may not work independently or cooperating manner. That means assume from the admission department all the faculties are getting information related to the students. From the library section, from each faculties are getting information or students are getting information. Similarly, from the administrative section, all the departments are getting information. That means they all are the cooperating processes. Now, who are the independent process? Independent processes completely those people are not directly involved into the sharing of any information, but they are the part of the system. Just maybe there are some private commons, private restaurant or private tea stall or cafeteria. Those are working within the campus or outside the campus. So these people are independent process, but they are related to the system. Okay. Next one is the convenience. Convenience means even a single user may work on different tasks at a time. For example, a user may be editing, formatting, printing or compiling in parallel. So for the sake of convenience, IPC is also a effective tool. Sorry. Next one, how many types of interprocess communication are available? Usually there are two approaches we followed. That is, one is the shared memory, another one is the message passing model. So what is the shared memory model? In shared memory model, a region of memory which is shared by cooperating processes gets established. Processes can be able to exchange information by reading or writing all the data to the shared regions. But in case of message passing model, communication takes place by the way of message exchanging among the cooperating process. So now I will go to the detail in shared memory system and also in the message passing system. Just go through the diagram. There are two processes, process 1 and process 2. In between process 1 and process 2, there is a shared region. So this shared region will be managed by the kernel. So in this case, process 1 is using the shared region and process 2 is also using the shared region. So what is happening? So in interprocess communication usually utilizes shared memory that requires communicating processes for establishing a region of shared memory. Typically, a shared memory region resides within the address space of any process, creating the shared memory segment. Other processes that wish for communicating using these shared memory segments must connect to their address spaces. The operating system tries to check the process from accessing other processes' memory. Shared memory needs two or more processes agree to remove this limitation. Then can they exchange information via reading and writing data within the shared areas. The form of data and location get established by these processes and are not under the control of operating system. So these shared memory region are not under the control of operating system. The processes are also in charge to ensure they are not writing to the same old location simultaneously. So these are the facts you have to remember in case of shared memory. So what is the need of the shared memory system? Why we need this? So as we have learned above, the operating system never allows a process to execute the memory space of another process. But what if two processes need to communicate and share data? We must provide an environment to the process where they can easily exchange data with each other. Next is the communications processes are two types. One is called the related communication, another one is called the unrelated communication. So related processes is now the interrelated process share data using pipes, but the unrelated processes communicate or share data using popular inter-process communication technique that are shared memory system and message passing. Leaving message passing for later, we will focus right now on the shared memory system. In shared memory model removes the restriction from the processes that no process will access each other memory. By establishing the shared region in the process's address space. This shared region in the address space of the memory is used for exchanging information between the cooperating process. So we need shared memory system for sharing information between the cooperating processes. It will also speed up the computation power of the system. So that means whenever there are related processes are concerned, in case of related processes, there are operating system pipes are using. But in case of unrelated process where you cannot use any operating system pipes, in that case you have to use the concept of inter-process communication by the means of shared memory or by the means of message passing model. But in case of shared memory, there is one restriction. Process 1 will be limited within its region, process 2 will be limited within its region. There is only a shared memory location. These particular region are shared between these two processes, process 1 and process 2, or many other processes also. So similarly, this thing you have to keep in mind. So what are the advantages of using shared memory model? Number one, shared memory system is faster inter-process communication model. Shared memory model allows cooperating processes to access the same piece of data concurrently. Number 3, using shared memory also speed up the computation power of the system as long as the task can be divided into smaller subtasks and can be executed in parallel. Number 4th reason is the modularity. So modularity can also be achieved if we divide up the system function into separate processes or threads. Number 5, using shared memory, user can perform multiple tasks at a time. Like user can print, create document, playing MP3, downloading movie, anything can be possible at the same time. So these are the 5 advantages of shared memory model. I am again repeating. Number 1 is the faster communication. Number 2 is the shared memory allows access of same data concurrently. Number 3 is increase the speed up of the system. Number 4 is the modularity, that by which you can access or you can execute separate portion of the particular task. And the 5th one is the by the using of shared memory, user can perform multiple tasks at a time. That is the multitasking facility. So there are some disadvantages also. What is the disadvantage? all the processes that uses the shared memory model need to make sure that they are not writing to the same memory location. So they are not writing the same memory location that need to be kept in mind. This is one main disadvantage of shared memory model. So process 1, process 2 can also editing or can also edit the same portion of the memory, and this will create the inconsistency or some problem for future. So number 2 is shared memory model may create problems such as synchronization, memory protection that need to be addressed. Okay, so these are the two main problems in case of shared memory model. Now number 2, that is the message passing model. Just see the diagram. There are n number of process, process 1, process 2, dot up to process n number of process. So in each process there are some local memory location 1, memory location 2 and memory location for kernel also. So whenever process 1 wants to share some data to process 2, first process 1 inform kernel will receive the data. This data will be again copied to the process 2. So process 1 and process 2 cannot interact to each other directly, but process 1 and process 2 can pass data or messages from process 1 to process 2 by the help of kernel. So kernel is the intermediate media over here. So message passing model allows multiple processes to read and write data to the message queue without being connected to each other. So messages are stored on the queue until their recipient retrieve them. Message queues are quite useful for inter-process communication and are used by most operating systems. In the above diagram, both the process 1 and process 2 can access the message queue and store retrieve data. Okay, so in kernel can handle a separate message queue. That thing you have to remember. So there are some advantages. Number 1 advantage, message passing model is much easier to implement than the shared memory model. Number 2, it is easier to parallel hardware using message passing model as it is quite tolerant of higher communication latencies. Disadvantages are this model is slower than other system and it takes much more time. Number 2, it is useful for sharing small amount of data. It is useful in only in distributed environment. You cannot use the message passing model in any other environment. These are the restrictions. So these are the comparison between shared memory model and the message passing model. Number 1 thing, shared memory model. In shared memory region is used for communication and message passing facility is used for also communication. It is used for communication between processes on a single processor or multiple processor system where the communication processor resides on the same machine as the communicating process share a common address space. That means a shared memory model shares a common address space. But in case of message passing model, it is worked in distributed environment where communicating process resides on remote computer also. So shared memory will be within a single computer system, but in case of message passing model, you can use the remote login methodology also. So number 3, the code for reading and writing data from the shared memory should be written explicitly by the application programmer. In case of message passing model, just go to the number 3 part. No such code required here as the message passing facility provides mechanism for communication and synchronization of action performed by the communicating processes. So in case of message passing model, no separate code is required, but in case of shared memory model, separate code is required. Number 4, it provides maximum speed up of computation as communication is done through shared memory. Two system calls are made only to establish the shared memory, but in case of message passing model, it is time consuming as message passing is implemented through kernel. So in case of shared memory model, kernel is not involved, that is why you can utilize the maximum speed up of computation. But in case of message passing model, here kernel is involved, that is why you cannot achieve the maximum utilization of the speed up from the system. So number 5, here the process needs to ensure that they are not writing to the same location simultaneously. So in shared memory model, you have to keep in mind you cannot write the same, cannot execute the same write operation at the same memory location. Similarly, it is useful for sharing small amount of data as conflicts need to be resolved. So shared memory model is faster and message passing model is slower. These are the basic difference you have to remember. Okay. So next I will go to the next part of our syllabus, that is the interaction between processes and operating system. Okay. So one kind of interaction we have already studied. One is called the inter-process communication. But how this inter-process communication actually going through, that means whatever the processes function, what are the resources are available, they all are interacting with our operating system. Interacting with our operating system means it is interacting with the kernel of your operating system. Okay, so kernel is the core component of your operating system. So there is a way, or there is a tool provided by your operating system, that is called the system. So now just go through the number 1 point. Processes interact by making system calls into the operating system, full stop. Though we will see that for stability, such calls are not directly calls to kernel functions, programming interface to the service provided by the operating system. Just like any other operating system perform, that is open file, close file, save file, read file, any other, whatever the single tips of action in your system, clicking mouse, downloading something, you want to open something, just pressing enter button in your through your keyboard, that means everything you are calling a system call. You are calling a system call. So system call is nothing but a signal which will carry extra features or value to inform your kernel that means you have to do right now this kind of operation. Okay, so in computing, a system call is the programmatic way in which computer program request a service from the kernel of the operating system it is executed on. Number 3, a system call is a way for programs to interact with the operating system. Number 4, a computer program makes a system call when it makes a request to the operating system kernels. So system calls provide the services of the operating system to the user programs via application programming interface. Next point, it provides an interface between a process and operating system to allow user level processes to request service of operating system. System calls are the only entry points to the kernel system. All programs needing resources must use system calls. Okay, so these are the diagram. So just remember the diagram from the first class. I have already told you the first level in the top of the system, that is the user program. Next is the user interface. Next is the system calls. Next is the different component of your system, that is the program control, IO control, file system, communication, error management, resource management, auditing, security. and at the bottom of the system, that is your computer hardware. Okay, so between user program or user interface, just see the green portion of this diagram. Here is the system call is in between an interface between the hardware and hardware related different component or the drivers of the system. So just go through the definition. A system call is a mechanism that provides the interface between a process and the operating system. So it is a programmatic method in which a computer program requests a service from the kernel of the OS. So system call offers the services of the operating system to the user program via application programming interface or API. So system calls are the only entry point for the kernel system. Okay, so this is the just see the green portion of this diagram. It is the in between person between user interface or the user program and your operating system. So it is the communication medium between user program and your operating system. Okay, so this is just go through the diagram. How system call works. Number one step, the processes execute in the user mode till the time a system calls interrupts it. Number one, user process executing, and first it will call a system call. Number two step, after the system call is executed, the kernel mode on a priority basis. So whenever a system call is called after number two step, that means your program control or system control will go to the kernel mode. Okay, number three, once system call execution is over, control return back to the user mode. So again, if from the execution of the system call has been occurred, then control will again come back to the user mode. So number four, the execution of user process resumed in kernel. Okay, so these are the steps in system calls. Now, why do you need system call in operating system? Why it is important? So number one, reading and writing from files demand system calls. Whenever we want to open a file, store a file, want to write something on a file, everything will be done by the system call. If a file wants to create, delete, system calls are required. System calls are used for creation, management of new processes. System network connections need system calls for sending, receiving packets. That means you are interacting with your internet or any chat box in your mobile or from your computer or laptop. That means everything will be initiated by the system calls. Those are handling the network connections. So access to hardware devices like scanner, printer, any other thing attached to your system like pen drive, anything. For everything system call is required. Okay. So what are the services provided by the system call? Process creation and management, main memory management, file access directory and file system management, device handling, protection and networking. These kind of services are provided by the system calls. So what types of system calls are available? Just see the diagram. Process control system call, file management system call, device management system call, information management system call, communication management system call. So in this case, we are mostly use system calls are process control and the file management. What are the process control system calls are there? Like process end, abort, create, terminate, allocate, free memory. These kind of system call are under the process control. For the file management, create, open, close, delete, read file, etc. So these are the types of system calls you have to do. So these are some details of system calls. So under process control, just go through the what are the function are used: end, abort, load and execute, create process and terminate process, wait and sign event, allocate and free memory. These are the system calls for process control. So under file management, what are the functions are using? Create file, delete file, open file, close file, read, write, requisition, get, set, file attributes. These are the system call are used. For device management, there are the system calls are used, mainly the attach, detach, get, set device, request and release device. Okay, so information maintenance, get or set time, date, get, process, device attribute. These are the system calls. For communication, these type of system calls are specially used for inter-process communication. Okay? So these are some important system call used in operating system. The number one is the wait. So in some system, a process need to wait for another process to complete its execution. This type of situation occurs when a process creates a child process and execution of parent process remains suspended until its child process executes. The suspension of the parent process automatically occurs with a wait system call. When the child process ends execution, the control moves back to the parent process. So just like wait means assume you two friends are going to a market and you told your friend you have to wait here for 15 minutes, then you will go to the shop, buy everything, again you come back to your friend, then the suspension of waiting process will be removed and again you both will come back to the home. The next one is the fork system call. Processes use this system call to create processes that are copy of themselves. That means whenever fork system call is called, that means you are creating another copy of yourself. With the help of this system call, parent process creates a child process and the execution of parent process will be suspended till the child process executes. Okay, so until child process complete its execution, parent process execution will be suspended. Okay, next one is the exit. This system calls runs when the executable file in the context of an already running processes that replaces the older executable file. However, the original process identifier remains as a new process. It is not built, but stack, data, head, data, etc. are replaced by the new process. Next one is the kill system call. The kill system call is used by operating system to send a termination signal to a process that urges the processes to exit. However, kill system call does not necessarily mean killing the process. Can have various meanings also. Okay, so whenever we will do our laboratory section, we will call all these system calls and we will get the practical experience of that also. Next one is the exit. The exit system call is used to terminate program execution, especially in the multi-threaded environment. These calls defines the thread execution is complete. The waste reclaims sources that are used by the process after the use of exit system call. Okay, so these are the things you have to remember. That is wait, fork, excel, kill, exit. They are the most popular system call used by your operating system. So these are the some list are here, mainly Windows and Unix are using. In case of Unix, in Windows functionality are quite similar, but name are different. So whenever we will do in our lab section through Unix or Ubuntu, we will learn how to call the process control system call by the help of fork, exit, wait. For file manipulation, open, read, write, close. For device manipulation, read, write, IOCTL. Information maintenance, get, PID, alarm, sleep. Communication for pipe, SH, MGET, MMAP or mmap. For the protection, chmod, umust, chone. This kind of system call we will use in our laboratory section also. And similarly, you have to remember Windows related system call, but the functionality are similar. Okay, so this thing you have to remember for your syllabus. So these are the books you can go through. For system call, I will suggest if you go through the books of shell programming or any other thing, that will be also very much helpful. So these are the important questions. You have to prepare short notes for shared memory model with diagram, message passing model with diagram. You have to know the differentiation between cooperating process and independent process. You have to know prepare the definition of system call, how does a system call execute. You have to explain the different functionalities of wait, fork, exit, kill and exit system call also. Why system calls are important, and most important thing, you have to differentiate shared memory model versus message passing model. These are the questions are important for your semester interview, as long as for your semester exam, as well as for your campus interview, any other interview also. Okay, so thank you. These are the link, you can get in touch with me, and if you have any confusion regarding your class, you can drop your message in the comment section, or you can directly communicate with me by the help of email. My LinkedIn account, my Facebook page, everything is given over here. So thank you students for your patience and attending the classes.